Hi everyone, welcome to this video. Today we will discuss the solution of chemistry section of JEE Advanced 2024 paper 2. To check the solution of paper 1, please go to our YouTube channel. It is already uploaded there. So let's get started with the solution. First question says, according to Bohr's model, the highest kinetic energy associated with the electron. Now the kinetic energy of electron is given by the formula RH Z square by N square, which is basically negative of electronic energy, right? So this is the kinetic energy. So basically we have to check in this question the value of the ratio of Z square by N square. For hydrogen, Z is 1, N is also 1, so the ratio is 1. For helium, Z is 2, which is 2 square divided by 1 square, so this comes out to be 4. For second orbit of helium, Z square is 2 square divided by N is 2, so that also comes out to be 1. Second orbit of lithium, Z is 3, so it's 3 square divided by second orbit, so this is 2, so that is 9 by 4, that is 2.25. So the correct answer to this question is option B. Moving to the second question, in a metal deficient oxide sample MXY2O4, where M and Y are metals, metal is present in both +2 and +3 oxidation state. The oxidation state of Y is given to be +3, and it is also given that the fraction of M2 plus ion is 1 by 3. The question is, what is the value of X? That is, what is the coefficient of metal in the formula of the compound? Alright, now for M2 plus the fraction is 1 by 3, then obviously for M3 plus the fraction would be 2 by 3, 1 minus 1 by 3. The charge on M2 plus is 2, so the total charge is 2 by 3, and the charge of M3 plus is 3, so the total charge on M3 plus ions would be 2. The sum of these charges, 2 by 3 plus 2, so this would be 8 by 3, so that is the average oxidation state of metal. Alright, now we know that the sum of oxidation numbers of all the atoms in a compound is 0, so let us apply that logic. Let's say there are X metal atoms and the average oxidation state is 8 by 3. So the total charge on X metal ions is 8x by 3. Plus there are 2 atoms of Y and the charge on each Y is 3. There are 4 oxygen and the charge on each oxide ion is -2. So this equals 0. So this is 8x by 3 plus 6 minus 8 is equal to 0. Upon solving, this is 8x by 3 is 2, which is x 3 by 4, that is 0.75. So the correct answer to this question is option D. Question number 3, all these reactions can be found in NCERT textbook of hydrocarbons and biomolecules. Let's start with the question. In the following reaction sequence, the major product Q is. The question is, what is the structure of Q? Now L-glucose, if you take, then upon reaction with HI, it is completely reduced to alkane. So glucose contains aldehyde and alcohol groups. So these are reduced to alkane upon reaction with HI. So the product after reaction with HI would be N-hexane. When N-hexane is reacted with Cr2O3 at high temperature and pressure, this is aromatization and produces benzene. Reaction of benzene with chlorine in the presence of ultraviolet light produces benzene hexachloride. That is option D is the correct answer to this question. Moving to the next question, the species formed on fluorination of phosphorus pentachloride in a polar organic solvent are. Now I would call it rather unusual question because I did not find this in common textbooks of inorganic chemistry. The correct answer to this question is this: when PCl5 is fluorinated in polar organic solvent, there are two types of products that are formed. You should also remember that in polar solvents or in ionic state, PCl5 exists as PCl4 plus and PCl6 minus. By the way, the correct answer to this question is option 2. Moving to section 2, an aqueous solution of hydrazine is electrochemically oxidized by oxygen, thereby releasing chemical energy in the form of electrical energy. One of the products generated from electrochemical reaction is N2. Here we can see that N2H4 is converted to nitrogen. If you calculate the oxidation numbers, the oxidation number of nitrogen changes from -2 to 0, that is nitrogen undergoes oxidation. So we can write the half reaction at anode as this. 1 molecule of hydrazine reacts with 4 molecules of hydroxide. It produces 1 molecule of nitrogen, water, and 4 electrons are released. At cathode, oxygen gas is reduced. So oxygen reacts with these 4 electrons in presence of 2H2O and it provides 4 OH minus. So yes, the first statement is correct. OH minus ions react with hydrazine at the anode to form nitrogen and water, releasing 4 electrons to the anode. At the cathode, N2H4 breaks to N2. Incorrect, because a cathode is by definition an electrode at which reduction occurs, but we have seen N2H4 undergoes oxidation, not reduction. At cathode, molecular oxygen gets converted to OH minus. Yes, molecular oxygen changes its oxidation state from 0 to -2, undergoes reduction. Oxides of nitrogen are major byproducts of electrochemical process. No, this is not correct. So the correct answer to these questions are option A and option C. Moving to the next question. So we will solve these questions in very short manner. The option with correct sequence of reagents for the conversion of P to Q. Okay, the reagents and different combinations are in different sequence are Lindlar's catalyst, SnCl to HCl, which is Stevens reduction, NeBH4, a reducing agent, followed by acidic hydrolysis. All right. Now let me tell you straight away the correct answer to this question is option C and option D. How? Let's see first option C. NaBH4 will reduce this keto to alcohol. So this is achieved. Reaction with SnCl2 will convert cyanide to CHO. That is a Stevens reduction. Nitriles on reaction with SnCl to HCl, they get converted to RCHO, aldehyde. Hydrolysis will remove this acetyl group. It will give OH and also convert this COET group into carboxylate. All right. Then Lindlar's catalyst will finally convert these carbon-carbon triple bonds into cis double bonds. So the desired conversion can be achieved using the sequence of reagents given in option C. Coming to option D, reaction with Lindlar's catalyst converts the triple bond into double bond. So that is achieved. Then if we react it, so this is achieved basically with Lindlar's catalyst. When you reacted with NaBH4, so this conversion is also achieved. When you reacted with nitrile, so cyanide is converted to CHO, and finally on acidic hydrolysis, this group is removed, it converts to OH, and this ester is also hydrolyzed, yielding carboxylate. So using option C and D, we can achieve the desired conversion. We can observe what happens in option A and B. When you reduce the molecule with Lindlar's catalyst, yes, the carbon-carbon triple bonds are reduced to carbon-carbon double bonds in cis configuration, but subsequent reaction with SnCl2 will produce CHO. You would think it is desired, yes, but on subsequent reaction with NaBH4, it is not only this carbonyl group that gets reduced to a secondary alcohol, but aldehyde will also be reduced to primary alcohol. Now that is an undesired outcome. So we cannot use option A. Similarly, we cannot use option B as well because the reaction with SnCl to HCl is followed by Lindlar's catalyst, which is followed by NaBH4. So this sequence of reagents cannot be used. NaBH4 has to be used before SnCl to HCl. Moving to question number 7, a very easy question. There have been many questions based on the oxoacids of different nonmetals in JEE Advanced. The compounds having peroxide linkage is R. So you basically have to know the structure of these oxoacids. H2S2O7 is this. It's basically pyrosulfuric acid with an SOS linkage but no peroxide linkage. H2S2O8, yes, it contains one peroxide linkage. It is also called peroxodisulfuric acid or Marshall's acid. So here we have a peroxide linkage. Then H2S2O5, no, this is pyrosulfurous acid. It contains sulfur-sulfur linkage but not sulfur, not oxygen-oxygen linkage. Finally, H2SO5, yes, again this is famous, peroxomonosulfuric acid or Keras acid. It has multiple names and it also contains a peroxide bond. So the correct answer to this question would be option B and D. Moving to the next section, which is section 3, questions from physical chemistry initially. This question was easy, in fact, question number 8. to form a complete monolayer of acetic acid on 1 gram of charcoal. 100 ml of 0.5 molar acetic acid was used. Now at this stage, guys, I would recommend that you pause this video, solve the question yourself, and then cross check your answer. Alright. So I'll straight away start with the solution. The charcoal is given to be 1 gram. So the surface area of the charcoal is 1.5 into 10 to minus 10 to power plus 2. So which is 150 meters square. Alright. Acetic acid is 0.5 molar and 100 ml. So number of moles of acetic acid initially used is 0.5 mole multiplied by 100 ml. So this is basically 50 millimole. Now, some of the acetic acid is adsorbed on the surface of charcoal, whereas the remaining remains in the solution, which is neutralized with NaOH. So, number of moles of NaOH consumed in neutralizing the unused acetic acid would be 1 molar multiplied by 40 ml, so that is 40 millimole. So, yes, we can see that out of 50 millimole acetic acid, 40 millimole acetic acid is neutralized by NaOH. So, the acetic acid that is adsorbed on the surface of charcoal, which is it is 50 minus 40, that is 10 millimole, or you can say 0.01 mole. All right. We can also convert it to an exact number by multiplying it by Avogadro constant. So that will give us 6 into 10 raised to the power 21 molecules. All right. Now we are at the last step in the solution. Each molecule occupies P into 10 to the power minus 23 meter square area, and there are 6 into 10 to the power 21 molecules, and we know the total area of the adsorbent in this case is 150. That is, there are 6 into 10 raised to the power 21 molecules, and each molecule occupies P into 10 to the minus 23 meters square, so the total area covered is given to be 150. Alright, so this we can solve 150 divided by 6, and this would be minus 2, and it would be 100. So this would come out to be 2500. So the correct answer to this question was 2500. Moving to the next question, question number 9. There are two vessels. Again, you can pause the video, read the question carefully, pick pen and paper, solve this question, and then you can replay the video and cross check your answer. There are two vessels, both contain the same solvent, water, the same amount of the solvent, W 1 gram, but they contain different solutes. One contains X, another contains Y. Again, their amounts are same. Alright. Now we know that the elevation in boiling point is given as I kb m, and molality requires three terms: mass of the solute divided by molar mass of the solute and mass of the solvent. You can read the question and realize that actually the mass of solute and mass of solvent, they are equal. So the only term, if we form the ratio, will come the elevation of boiling point of X divided by elevation of boiling point of Y. It would be I of X divided by the, Kb will be cancelled, the molar mass of X, and multiplied by I of Y multiplied by the molar mass of Y. Now you can read the remaining question. The molar mass of X is 80% that of Y. Molar mass of X is 80% that of Y. So if the molar mass of Y is 1, alright, the molar mass of X is 0.8. The Van 't Hoff factor for X is 1.2 times that of Y. Okay, so the Van 't Hoff factor for X is 1.2 times that of Y. So you can solve this. This will come out to be 3 by 2. That is, the elevation in boiling point of X is to the elevation boiling point of Y is 3 by 2, that is 150%. So the correct answer to this question would be 150. Moving to the next question, a very easy question from biomolecules, calculation based. The DNA is double stranded. We know that A pairs with T and G pairs with C. The question is amount of energy required to split the double bond strand DNA into two single strands. Okay, so this is very easy question. First, you have to count the number of A plus T. Then you have to count the number of C and G. AU is useless because DNA does not contain uracil. Let us solve this question. How many A and T's are there? 1, 2, 3, 4, 5, 6, 7. So there are 7 A plus T. And remember guys, each pair of adenine and thymine forms 2 double bonds. So the total double bonds are 14, and the strength of each double bond, strength of each hydrogen bond is 1 kilocalorie. Okay, so I think I said it incorrectly. Each pair of adenine and thymine forms 2 hydrogen bonds, I wanted to say, right? So in total there are 14 hydrogen bonds, and each bond has 1 kilocalorie strength. So the total hydrogen bond strength would be 14 kilocalorie. All right. Then let us come to CNG. How many CNG are there? 1, 2, 3, 4, 5, 6. There are in total 6 GNC. Each guanine and cytosine pair forms 3 hydrogen bonds, and the strength is given to be 1.5. So this is coming out to be 27. So the answer would be 41 kilocalorie. All right. Moving to the next question. Question number 11. A sample initially contains only U-238 isotope of uranium. With time, some of the U-238 radioactively decays into lead-206, while the rest of it remains undisintegrated. The age of the sample is given. It has an unknown number, that is P. The ratio of the mass of lead-206 to that of U-238 is found to be 7. The question is, what is the value of P? So guys, tell me in the comments if you could solve this question without using any additional logarithm values, because I discovered that you actually need some other log value also, like log 9.0 something. Okay, so I'll anyway tell you how to approach this question. The mass of lead and the mass of uranium is the ratio is 7:1. Okay, so we can say that number of moles of lead is 7 by 206 mass upon molar mass, and the number of moles of uranium is 1 by 238. Okay, now each uranium gives rise to lead. So the initial number of moles of uranium is the number of moles of uranium present now and the number of moles of lead atoms formed. So that is 7 by 206. Okay, now we know that radioactive decay is of first order, and for first order integrated rate equation is T is equal to 1 upon K ln initial concentration of uranium and the concentration of uranium at time T. Also, rate constant is ln2 by half-life. So this is ln2. The value of ln2 is given 0.693. Half-life is 4.5 into 10 raised to the power 9. Okay, this is 4.5 into 10 raised to the power 9. Ln initial amount of uranium is 1 by 238 plus 7 by 206 divided by the final amount of uranium is 1 by 238. You can work out this and you will find that this is approximately ln 9.08. In question, nowhere the value of ln 9 is given. Okay, so when I worked out this question by checking out the value of ln 9, the answer comes out to be approximately 143. Now you guys also solve this question and tell the answer in the comment section. Moving to question number 12. The total number of species with tetrahedral geometry. Okay, now 4 coordinate complexes can have 2 possible geometries, which could be sp3, that is tetrahedral, and square planar, which is dsp2. Okay, now you have to check which of them are tetrahedral. So P4 right away, yes, it is tetrahedral. It is like this. Okay, CuCN43 minus, is it tetrahedral? Yes. I don't think it can be. You can check it out. For example, copper here is Cu is in +1 state, so copper is 3d10, 4s1, and when one electron from 4s goes, it gives you 3d10. That is, you do not have any d orbitals, so the hybridization would be sp3. So we have to check it out. Yes, it is tetrahedral. All right. ICl4 minus, it has 7 plus 1, 8 electrons. So 4 bond pairs and 2 lone pairs, so it has octahedral geometry. So this is not uh, transition metal complexes of heavy metals, right, where the ligand is weak field, they are square planar, because the crystal field stabilization energy for square planar is significantly higher than those for tetrahedral as you move down the group in the periodic table. So PdCl42 minus will be square planar, not tetrahedral. PCl4 plus, yes, it would be. The steric number is 4. You can calculate. Phosphorus Cl4 plus looks like this. XeF4, again it has a steric number of 6, right? It is octahedral geometry, so this is not true, right? So here we have got 1 and then 2 and then 3, and both these complexes are tetrahedral because cobalt cyanide is 4 and there are 4 minus charges, so cobalt is in 0 oxidation state. 3d7 4s2, that is when paired up into d orbital, this is 3d9. So we do not have any unpaired, we do not have any d orbital available for hybridization. So both these would be undergoing sp3 hybridization. So the total number of molecules that would be tetrahedral would be 5. Moving to question number 13, an organic compound P having molecular formula C6H6O3. It is clear from the formula itself that the degree of unsaturation is high. Since it gives ferric chloride test, it has to have a phenolic group, right? The moment you draw benzene, you are exhausted a 6 carbon atom. You have exhausted 6 carbon atom. So if this is OH and the molecule does not form intramolecular hydrogen bond, so two OH groups cannot be ortho with respect to each other. Otherwise, they would be engaged in intramolecular hydrogen bonding. The compound P reacts with 3 equivalents of hydroxylamine. It suggests that phenol converts to its enolic form. Yes, phenol is enol. It is more stable due to aromatic nature. But if it reacts with hydroxylamine, it has to come in this form, right? So we are drawing the keto form of the corresponding enolic form. Yes, it will react with the hydroxylamine to produce an oxime Q. They haven't asked any question about Q, so we really don't need to worry about its structure, right? By the way, it will be this oxime. This is going to be Q. Coming to P with excess methyl iodide. Now, if you notice, it is an active methylene compound. The two hydrogens on these carbon atoms, they are acidic because of the electron withdrawing effect of carbonyl group. So when this molecule is reacted with excess of methyl iodide in presence of a base, then this compound gets converted to this. There are 6 methyls. Subsequently, the reaction of R with excess isobutyl magnesium bromide. Now, when you react this molecule with isobutyl magnesium bromide, so this is a nucleophilic addition of Grignard reagent on carbonyl, right? So this attacks here and the pi bond breaks. And what you get is on subsequent hydrolysis, this gives you OH and this is CH2, CH and then CH3 and CH3. Similarly, you can do the reaction on these carbonyl groups. What we observe is that there are in total 12 methyl groups, right? 1, 2, 3, 4, 5, 6, 7, 8, and similarly 2 will end up here and 2 will end up here. So the total number of methyl groups would be 12. Let's move to the next section, that is section 4. An organic compound P with molecular formula C9H18A2. The molecular formula indicates that the degree of unsaturation is 1, right? Since it decolorizes bromine water, it has to have a carbon-carbon double bond, and it also shows positive iodoform test. Positive iodoform test is shown by the molecules that have either this group or this group. All right. Now we cannot have a keto because that would require the presence of one more degree of unsaturation. So we have to have a secondary alcoholic group here. All right. So this is something like CH, OH, CH3. All right. So this is RP. When P is ozonalized followed by treatment with H2O2, it gives QNR. All right. So this bond breaks. So far we know that one would have carboxylic, another would also have carboxylic. H2O2 initiates the oxidative cleavage of the ozonide intermediate, right? So the carbon-carbon double bond will give you 2 carboxylic groups. This is what we know about the products Q and R. Okay, let's say this is Q and this is R. Now, while compound Q shows positive iodine test, yes, it will show positive iodine test because it still has this linkage. Compound R does not. Now, this is where you have to stop. Compound R does not give positive iodine test, yet there is one oxygen we have to account for. Okay, now this oxygen cannot be present in the form of a terminal OH group. Why? Because R is subsequently oxidized with PCC that gives positive iodoform test. You can read the question. When R is oxidized with PCC followed by heating, it gives iodoform test, right? So if it is CH2OH and then you oxidize it with PCC, that will give aldehyde, that will not give iodoform test. Okay. Also, it cannot have this group because otherwise R would give us the iodoform test. So the possibility is that R could look something like this: CH3, CH2, CH, OH, CH2 and COH. Let us see if this structure is supported by the given information. Let us say this is the structure of R. Okay, it does not give positive iodoform test. Yes, it neither has COCH3 group nor CHOHCH3. When you oxidized with PCC, you get CH3, CH2, C double bond O and CH2, COH. When you heat this molecule, this is the decarboxylation reaction because there is an electron withdrawing group. This is carboxylic, this is alpha, this is beta. This is beta keto acid, a very famous reaction, probably a favorite reaction of JEE. It has come in the last years many times. CO2 disappears in this case and then you get CH3, CH2, C double bond O and CH3. That is the structure of the product formed by R. So Q and R on oxidation give S and T respectively. So this is the structure of T. And yes, both S and T show positive iodoform test. Yes, it will show positive iodoform test because it has now this methyl ketone linkage. Coming back to the structure of Q. Now you can deduce the structure of Q from the so far deduced data, right? Because we have 1, 2, 3, 4, 5 carbon here. So we have to have 4 carbon here. We cannot put 1 carbon here. So there is only one possibility, CH2. So actually the structure of Q, which we shall shortly verify with the given information, is this. All right. This is our Q. Now, when this is oxidized with PCC followed by heating, so you understand first this group will be oxidized to keto and then it will be carboxylic alpha and beta. Upon heating, the carboxylic will disappear. So this will be CH3, C double bond O and then CH3. So this will be the correct structure of T. All right. Yes, T will also give iodoform test because it has methyl ketone linkage. Coming to question number 14, the sum of oxygen atoms in S and T, you can see one oxygen in T and one oxygen in S. It is S, not T. All right, so this is S molecule. The molecule arising from the oxidation of Q is S. Yeah. So the oxygen in T is 1 and oxygen in S is 1. Right. So the sum of number of oxygen atoms in S and T is 2. Coming to the second molecule, complete polymerization of 500 moles of Q and 500 moles of R gives 1 mole of a single acyclic copolymer Q. And the question is, what is the molecular mass? So this was rather an easy question now. Now that we know the structures of these molecules, so the polymerization is happening between Q and R, right? This is Q and this is R. Okay, you can calculate their molar masses. Let's say the molecular mass of Q is MQ and the molecular mass of R is MR, and there are 500 molecules, so the total mass would be 500 times. Okay, now when one molecule of Q combines with R, an ester linkage is formed, right? One molecule gives carboxylic, other gives alcohol, and then water is eliminated, and that gives an ester linkage. Similarly, third molecule attaches, a water is eliminated. So addition of 1000 molecules will result in the elimination of 999 molecules of water. So the mass eliminated is 999 into 18. That will give you the mass, molecular mass of U. If you work it out, the correct answer would be 93018. Okay, 93018. You can work it out. You can find out the molecular mass of Q from here, molecular mass of R from here, and then subtract 999 into 18 from this. Coming to the last segment of this, paragraph 2. This was rather an easy question if you observe carefully. When potassium iodide is added to potassium ferricyanide, ferricyanide is K3FeCN6. Alright, so if you observe, iron is in +3 oxidation state, it will undergo reduction to form potassium ferrocyanide, and iodide will be oxidized from -1 to 0. Alright, so obviously you need 2 moles of Ki here. Okay, with the 2 moles of this, so this is this, right? The number of moles of potassium iodide required to produce 2 moles of P is obviously 2, because iron gains 1 electron, iodide loses 1 electron. So to produce 2 moles of P, you need 2 moles of Ki. Now when P is reacted with zinc ions, so an ion exchange happens, zinc exchanges potassium. So you could either get this due to the polarizing nature of zinc. This compound is sparingly soluble in water. So the number of zinc ions present in the molecular formula of Q is 2. Now there is another product possible by the reaction of zinc ion with P, which is this K2Zn3 Fe Cn6 and twice. Okay, so the answer to this question could also be 3. Let's wait for the JEE answer key to come out. What answer have they selected as the correct one? So that's all in the solution of this chemistry section, guys. Thank you for watching till the end. Please subscribe to this YouTube channel to stay updated with the videos I upload in the future. I'm sure they will be very helpful for your preparation in JEE Advanced 2025 or 26. Thank you.